All right, here is chapter 7 homework number 8. It's super similar to number 7, so hopefully it's not too bad. So according to a certain organization, adults worked an average of 1,853 hours last year. Assume the population standard deviation is 380 hours and that a random sample of 50 adults was selected. So again, I'll start with what I know. So our population mean is 1,853. Population standard deviation is 380. Our sample size, N, is 50. So the first thing is calculate the standard error of the mean. And we know that the standard error of the mean is the population standard deviation divided by the square root of N. So 53.74. All right, what is the probability that the sample mean will be more than 1,880 hours? So in order to figure that out, we have our X bar. In this case, it's 1880. And then we're going to have to find our Z-score for that X bar. So our Z-score is going to be our X bar minus our population mean divided by the standard error of the mean. So that's our Z-score for that level of X bar. So then our probability that is less than is an equal norm.s.distribution or .dist for that Z-score comma true, and our probability greater is going to equal 1 minus the probability that it's less than. So the probability that it is greater than 1880 is 0.3077. All right, the probability that the sample mean will be between 1820 and 1840. So again, I'll do 1840. So I'm going to do the probability less than 1840, and that's going to equal and then we'll find the probability that it's less than 1820. And then the probability that it's between the two is just going to be the difference. And there's our probability that it's between those two, 0.1348. All right. So the question is, would a sample mean of 1,880 hours support the claim made by the organization? So we'll come up here and we'll plug in 1880, which we already did. So when we did 1880, we see that our probability was 0.3077. So we would say the probability that X bar is greater than 1880 is 0.3077, and that supports the claim. All right. Finally, we have to identify a symmetrical interval that includes 95% of the sample means. So to do that, we're going to find the Z of our upper bound and the Z of our lower bound. The Z of our lower bound, our upper bound, is going to be that point at which the probability is 0.975, meaning there's 2.5% above. And then the Z of our lower bound will be where the probability is 0.025, meaning there's 2.5% below. So the Z-scores of this are going to be from negative 1.96 to positive 1.96. Now we have to convert these Z-scores into what the X bar would be at that point. That gets us back into our regular units. So the X bar of our upper is going to equal our Z-score of the upper bound times our standard error of the mean plus our population mean. And our x bar of the lower bound is going to equal our z-star of the lower bound times standard error of the mean plus population mean. 1 decimal place, so 1747.7 and 1958.3. Whoops. Yeah. And that's good. All right. So, like I said, questions 7 and 8 are really close to each other, really similar in the process. So, hopefully that's helpful. In fact, if you keep your calculator from 7, you should be able to use it in 8 again. So, hopefully that was helpful. Have a great day.